Question number 7 from NEST 2021 second shift. This question is from trigonometry. Trigonometric equations in particular. If tan of cot x is equal to cot of tan x, then one of the possible values of sine 2x is 4 by 41 pi, 2 by pi, 5 by pi and 3 by pi square. Okay. So they're saying one of the possible values is, so we know only one of the four options is going to be right. And also it is a multiple choice question. While writing the exam, it will be specified to you whether it is a multiple choice question or a multiple select question. Okay. Now the reason why I brought this point right at the beginning of our solution is that this is a trigonometric equation. And we know trigonometric equations usually have infinitely many solutions because of the periodicity. Okay. Okay. Also look at option C. Option C is 5 by pi, and because 5 is greater than pi, 5 by pi is greater than 1. Now can sine 2x or sine theta, can it ever be greater than 1? No, so C is directly gone. Okay, C is directly gone, so it is either A, B or D. Okay. Acha. Now look, let us first write down the equation given to us. So it's tan of cot x, okay, equal to cot of tan x. Okay, so on both sides we have got composite functions with inner and outer functions being interchanged, right? Acha. An allied angle formula now will come to our rescue because on the left side we have got tan and on the right side we have got cot. Now both these ratios or functions are related by the following identity. What identity is that? That identity is tan of theta, whenever it is defined, is cot of pi by 2 minus theta. If you don't know this formula, you can verify it using tan as sine upon cos and cot as cos upon sine. You can do that. Now, why is this identity useful here? Why not any other identity? Look, this is tan and this is tan, and here on the right side we have got cot and we have got cot here. Okay, we have got cot here. Now there is one more thing that I would like you people to note. Okay, you will realize the significance of that at a later stage, and that is because of the periodicity. Okay, I am going to write this as cot of 2n pi plus pi by 2 minus theta. That's totally fine, because if our angle is okay, pi by 2 minus theta plus 2 pi plus 4 pi plus x pi, or minus 2 pi minus 4 pi minus x pi, it is still going to have the same ratios as pi by 2 minus theta. That step is important. Okay, so two things are important to solve the problem. First, that identity that we have written, and then we have brought in that 2n pi that has something to do with sine of theta not being greater than 1. Okay, it has something to do with that. We shall see. Okay, fine. Now let us apply the conditions here. Naturally, we would now like to put cot x as theta. Okay, so we will say let theta be cot x. Okay, let theta be cot x. Okay, let theta be cot x. But then what would tan x be? Tan x would be pi by 2 minus theta. Correct? Tan of something is equal to cot of something, and tan of theta is equal to cot of pi by 2 minus theta. The two things can now be changed. Correct? So look here. If theta is cot x, then tan x becomes pi by 2 minus theta, or pi by 2 minus cot x, because theta is cot x, right? Yes. Now we get another equation. Tan of x plus cot of x is equal to pi by 2. Okay, tan of x plus cot of x is equal to pi by 2. I have deliberately not included 2n pi. You will realize that it contradicts our it contradicts the fact that sin x is never greater than 1. Okay, now let's try to simplify this. Here. Tan is sine upon cos, right? Tan is sine upon cos. Cot is cos upon sine. Okay, so this is our LHS. Let us continue to simplify this. It is sine squared x plus cos squared x after taking the LCM, okay, upon sine into cos. And how much is this? This is 1 upon sine x cos x. Okay, this is 1 upon sine x cos x, or it is 2 by sine 2x. Okay, it is 2 by sine 2x. I hope everybody understood this, right? What have we done? What have we done? We have basically gone on simplifying this expression, and we have eventually arrived at this. Okay, we have eventually arrived at tan x plus cot x is equal to 2 upon sine 2x. Well, what identity have we used again? Sine, double angle formula, sine 2 theta is 2 sine theta cos theta. Okay, so therefore I can say 2 upon sine 2x is equal to pi by 2. Okay, 2 upon sine 2x is equal to pi by 2. Now we have to take the reciprocal now. So sine 2x by 2 is equal to 2 by pi, right? Sine 2x upon 2 is equal to 2 by pi. So what is sine 2x here? What is sine 2x here? Sine 2x here is 4 by pi. Now let us go back to the fact that we stated that sine theta can never be greater than 1. Now like 5 is greater than pi, 4 is also greater than pi. So 4 by pi will be greater than 1, and that is not possible. So sine 2x equal to 4 by pi doesn't have any solution. Okay, sine of 2x equal to 4 by pi does not have any solution. Then what? Let's go back to that 2n pi that we added, and I told you that let's first not include that and see what we get. We have got a contradiction. Sine of 2x is equal to 4 upon pi. So what will we do now? Okay, what will we do? Okay, there's nothing different that we will now do. It's just that in this term rather, look, what I am now going to do is, okay, I'm going to replace pi by 2 minus theta by 2n pi plus pi by 2 minus theta. That's the only change that I'm going to do. Okay, what? Pi by 2 minus theta, I will replace it by cot of, just inside 2n pi plus pi by 2 minus theta. Let's do it. Okay, let's do it. Meaning, let us make that change here. Let's make that change. Two n pi plus pi by 2 minus theta, or it is equal to 2n pi plus pi by 2 minus cot x. It's basically the same thing. Okay, pi by 2 minus theta replaced by 2n pi plus pi by 2 minus theta, and that gives us something. That now says that tan x plus cot x will not be merely pi by 2. It would rather be equal to 2n pi plus pi by 2, and that is something that will now take us to the final solution. Okay, we know, okay, from this step we know that 2 upon sine 2x is now equal to what? Earlier it was just pi by 2, but that got us to a contradiction, so we will now say 2n pi plus 1. Correct? 2n pi plus pi by 2. Okay, what can we then do? We can take pi common. Okay, we can take pi common, so it will be 2n plus 1 upon 2, right? 2n plus 1 upon 2, or pi into 4n plus 1 by 2. Okay, pi into 4n plus 1 by 2. Now take the reciprocal, which makes it easier now for us. So sine 2x by 2, okay, sine 2x by 2 is equal to 2 upon pi into 4n plus 1, and therefore sine of 2x is equal to 4 upon pi into 4n plus 1 with n. Okay, n can't be 0, because then it will be Okay, greater than or equal to 1, because in that case what would it be? It will be the old case, okay, the default case, which of course didn't work out because it will then give us 4 by pi if we take n as 0. So suppose we take n as 1, then what is sine 2x? 4 upon 5 pi. Okay, 4 upon 5 pi. It's not there, but don't worry, we'll focus on 4 upon 41 pi now. Okay, we will focus on that. Suppose we take n as 10. Suppose we take n as 10, then what will be sine 2x? If we take n as 10, then what will be sine 2x? 4 upon 10 into 4, 40 plus 1, 41, so 41 pi. Okay, so at least as far as the problem is concerned, we have got the solution to be option A. Okay, it was not 2 by pi and it was also not 3 by pi squared. Okay, now well, we have done all of that, that's very good, but then there's also one more connection that tan and cot share. Okay, and that connection, now I will show that to you. Okay, see, this is our answer, that when n is equal to 10, sine of 2x is equal to 4 upon 41 pi, and the solution that we did is right on our left. Okay, it's here, tan theta is equal to cot of pi by 2 minus theta, then we added that to n pi and we eventually got the solution. Okay, but there is one more way to solve the problem. And that is when you take tan theta as cot of 3 pi by 2 minus theta. That is also allowed. Okay, you can check that here. Okay, let's take tan x first. And then let us take cot of 3 pi by 2 minus x. That black one overlaps with this, so that can also be taken into consideration and we can simplify that also. Okay, which would I think give us with n equal to 0, it will give us 4 upon 3 pi, right? 4 upon 3 pi, and when n is, so that is again less than 1, but it is not present here, so we will accept option A. But if the question had been find the general solution, then we would have written all these things with, of course, taking note of the fact that sine 2x can be only in between negative and 1. Okay, all right, so that is question number 7.